Hi everybody, Mr. Rowe here. I'm just going to do a video lesson here on part 2 of 2.6, the measures of spread continues. So I did a video lesson for 2.6, part 1, measure of spread, which was standard deviation. So this is part 2, which is quartiles, interquartile range, and percentiles. This is going to be kind of like a hybrid. I have a little bit of the note filled out already, but I'll be filling it out along the way. So let's get to it. So just some key terms right off the hop. What is a quartile? So it's not that different from median. If you understand the concept of a median, that's the middle value of the data. A quartile just divides the set into 4 groups. So the first quartile would actually be the median of the first half of the data. So if this is the first half of the data, then Q1 is the median of that. And if I take the second half of the data, which is this, the median to the highest data point, that would be the third quartile. So the third quartile is the median of the second half of the data. The first quartile is the median of the first half of the data. And of course the median is the middle of the data. The median is also referred to as the second quartile. So this is just a recall on how to find a median. If there's an even amount of data points, then you just find the average. And if there's an odd amount, you can find that exact middle value. We'll see that when we go to do our examples. So just some other terms here, that an interquartile range, that can be calculated by taking the value of the third quartile and subtracting the first quartile. So basically what that does is it gives you the range of the middle half of the data. So the first quartile and third quartile make up the middle half of the data, and the interquartile range will give you the range of that. So the larger the interquartile range, the larger the spread of the central half of the data. And then they have another one here, semi-interquartile range. So same idea, it's just 1/2 the interquartile range. So once you have this calculated, you would just divide it by 2 to get this. So maybe I'll just write that. So it would be the interquartile range, which I'll refer to as IQR, divided by 2. Okay, so we'll also be making something called a box and whisker plot. You'll see this on your assessment as well. Basically what it does is it illustrates all the measures from the last page that we just talked about. First quartile, second quartile, third quartile, highest data point, lowest data point, interquartile range, etc. So this point here ends up being the lowest data point. Maybe I'll do this. So this left whisker is the lowest data point. Make that a little smaller, I think. Put that there. This point, the right whisker of the box, is the highest data point. And then we have the box itself. So the left side of the box is going to be the first quartile. So wherever that value is goes there. That line in the middle of the box is going to be the second quartile. And then way over here, you get the right side of the box, which is the third quartile. And you can see the length of the box is the interquartile range. Maybe I'll write that as well. Interquartile range would be this. Okay, so up until this point, so I guess we'll talk about this first. A modified box and whisker plot, which you'll also have to do on the assessment, perhaps, if applicable, includes outliers. Now, up until this point, we know that outliers are data points that don't follow the general trend of the data. Up until this point, we've just kind of used our discretion when determining an outlier. So you did this in grade 9, and you would look at a scatter plot and you'd say, oh, that's an outlier because it doesn't follow the trend of the data. Now, we're actually going to have a mathematical way to calculate if a data point is an outlier or not. So the mathematical way of determining if a data point is an outlier is that data point at least 1.5 times the box length away? If it is, it's an outlier. So we're going to do an example of this on the next page to see what I mean. But basically, if you have the box here, this is the length of the box, the interquartile range. So what this is saying is if you take the length of this and you multiply it by 1.5, so it's going to be about that long. If the data point is further away than that, it'll be considered an outlier, and if it is, you just put a dot there instead to show that point. So we'll see what happens in our example on the next page. So I've already started this question a little bit, and we'll finish it off together. So we're going to do all these calculations, including the box and whisker. So this is a random survey of people at a science fiction convention. They want to know how many times did you watch Star Wars. So here's the raw data. Okay, can't really make too much sense out of this, so we're going to organize it a bit. We're going to determine the median. So to determine a median or any of these calculations, we need this in order. So I went ahead and redistributed these. How many are there? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 20 data points. Let me just make sure I had them all. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 20. Okay, so we're good. So there's 20 data points. I need the median, so I got to put it in order, and now I need to find the middle. So if you remember, I have that little trick where if I take the number of data points, this is how you find the middle, and then I add 1 and divide by 2. So I'm finding the median, or in other words, Q2. I get 21 over 2. So you get 10.5. So this tells me that the middle of the data can be found by taking an average of the 10th and the 11th data point. So there's the 10th. There's the 11th. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So here's the 10th. Here's the 11th. The median Q2 is going to be right in the middle of this. So it's going to be an average of this. So it's going to be 5.5. Half the values are above 5.5 and half the values are below 5.5. Alright, so there's that. Okay, so now I need the first quartile and the third quartile. So I'll use a different color here. What I'm going to be aiming for is to now find the median of the first half of the data. Well, the first half of the data has 10 data points in it. So I can use this same kind of trick for Q1. I'm looking for the first half, the 10 points. I'm only considering the first half of the data, which is this. From here to here. Now I know you can probably do this with inspection, but it's good to know how to do this. Maybe, what if I give you like 137 data points? Then you're going to want to know how to find these very specific values. These examples are much smaller scale, so they're not as bad. So 5.5, so I'm going to want the 5th and the 6th. So 1, 2, 3, 4, 5, and 6. So it's right here. There's the 5th and the 6th. I want the middle of that. So it's going to be 3 plus 3, which is 3. 3 plus 3, and then the average of that. Alright, so then I'm just going to fill this in here. Q1. We want Q3. So this is going to be the median of the second half of the data. So again, there's going to be 10 data points. So it's going to be the 5th and the 6th of the second half of the data. Okay, so if you're doing this with a larger data set, you would add the 10 data points in front of it. So really what you're looking for is the 10 plus the 5th and the 6th. So you're looking for the 15th and 16th of the total data set, or the 5th and the 6th of just the second half of the data. So 1, 2, 3, 4, 5, and 6 would be these two. So Q3 is right here. Hopefully that made sense. If you know that there's just 10 data points in the second half of the data, you're looking for the 5th, the average of the 5th and the 6th in the second half. But if you had the whole giant, if you're looking in the context of the entire data set, it would be 10 plus 5, 10 plus 6, 15th and 16th. So just showing my work here, we know it's going to be 10. Alright, so we have most of the information we need to continue. It's now asking me for the interquartile range. So as we discussed previously, this is the range of the middle half of the data. So it's Q3 minus Q1. So it's going to be the third quartile we calculated was 10. The first quartile we calculated was 3. So the interquartile range, the range of the middle part of the data, is 7. And then the semi-interquartile range is just going to be half of the interquartile range. So you take the interquartile range and divide it by 2. So it's going to equal 3.5. So far so good. So now what we're going to do is we're going to put this on a box and whisker plot. So the first thing I'm going to do is I'm going to make the box and whisker plot. Then I'm going to go back and determine afterwards if there's any outliers. I could do that first, I guess. But I'm just going to do an original box and whisker plot with all the data on it. And then I'm going to go back and do the modified. I don't think it even asks about outliers. If it's not specified, you should probably do a modified box and whisker plot. So the lowest data point is 1 and the highest is 30. So I'm going to get a line here, make it black. Here's my lowest data point. Tried to make that at 1. My highest data point is at 30. So those are the whiskers. The box, the left side of the box is going to be the first quartile, which is 3. The right side of the box is going to be the third quartile, which is 10. So I will go ahead and do that. So there's 1, 2, 3, approximately right there. I'm going to go to 10. And then there's going to be another line in the box for the or the median, which is 5.5. So that would be right about there. Okay. And then you would go ahead and join these. So that's a box and whisker plot. You should also label it as well, so I'll take the time to do that. But there's a box and whisker plot. But what I need to know is there's this one, the highest data point 30. This guy who watched Star Wars an unhealthy amount of times here. We need to know, is this guy an outlier? So instead of just saying, it kind of looks like he is, we now have a mathematical way to decide if he is or not. So if you recall from what we talked about before, we're going to determine, is this point more than 1.5 times away from either side of the box? So specifically, we're looking at a point this way. So what I'm going to do is I'm going to take 1.5, I'm going to multiply it by the length of the box. How long is this box? Well, that's the interquartile range. So I'm going to go ahead and multiply that by 7. And then we'll use that to see how far away our data point is. That would be considered an outlier. So what this is saying is, if there's a data point that is 10.5 away from either side of the box, it would be considered an outlier. So here's the left side of the box at 3. So clearly, if we go down 10.5, we're in the negatives, which isn't possible in the context of this question. So there's not going to be any outliers to the low end. However, if we take this right boundary, so I'm going to do the upper boundary to determine an outlier. I'll move it in a second so we don't have this watermark. Well, it's going to equal 10, because that's this distance right here, 10. Is it 10 plus 10.5? So any point above 20.5 is considered an outlier. In general, the formula is this for the boundary. For the upper boundary, it's going to be, because this value is Q3, the upper boundary is going to be Q3 plus 1.5 times the IQR. That's going to give you the boundary. And the lower boundary will be Q1 minus 1.5 times the interquartile range. And that's just what we did. We took the value of the third quartile and then we added 1.5 times the interquartile range, which was 10.5. So I'm just going to draw this in. You normally wouldn't draw this in, but I'm going to just for demonstration here. So the 20.5 boundary is right here. So any data point above that is officially an outlier. So again, I'm just kind of doing this for demonstration. Here's the boundary. So is this guy who watched it 30 times an outlier? Yes. Is this person who watched an outlier? No, because he's less than 20.5. So what you're going to do, and again, hopefully you weren't copying this out, you're going to move this. This new highest data point is actually going to become 16, the next highest. So we'll shrink that down. And what we'll do instead is we'll acknowledge this guy at 30 times with a dot as an outlier. And again, just for good form here, we should label this these points. So this is Q1, Q2. You could even put the specific values as well. I don't have much room. You could do like Q3 equals 10, etc. There you have it. So this is a modified box and whisker plot. And you wouldn't have this on there. This was, again, just for demonstration. You determine the boundary that determines if it's an outlier. Any point above it's an outlier. Any point below it is not an outlier. Lastly here on this question, compare the results above to those from last year's, which found a median of 5.1 and an interquartile range of 8. So the interquartile range, I'll write this out later for you and put it on the completed note. We'll just talk through it right now just to save time. The interquartile range last year was 8, so that means the middle half of the data is a little more spread out. So this is why this is a measure of spread. So it's a little less spread out this year, the middle half of the data anyways, because the interquartile range is 7 compared to 8. And then last year it looks like we had a median of 5.1. And this year our median was 5.5. So the median has gone up slightly. So I'll fill this note, the rest of this note in it, and it'll be in the posted completed note. Moving on. So just quickly here, example 2. I've already kind of filled this out, got a little grid going here to help us with this. They want you to describe these mutual funds in terms of quartiles. So if you notice, we've taken, the entire data set here and we've broken it into the quartiles. Q1, Q2, Q3. So anything in here is in the first quartile because it's broken into quarters. So anything in here is in the first quartile, in the second quartile, in the third quartile, in the fourth quartile. If it's exactly on, then you'd say it is the first quartile, it is the second quartile, it is the third quartile. So where does TD value fit into this with their 7.5? Well, they're going to be probably around right here. So I'll go green for them. So how would we describe them? We would say they are in, maybe I'll do this smaller here. In the third quartile. Okay, Royal, go red. And they are at 9, so they're way up here. So we would consider them fourth quartile. And then lastly, we have BMO, Bank of Montreal, we'll do in blue. They're at 7.2. So they're right on the median. So that this fund would be a median performing fund. Right. All right, lastly, we're just going to talk about percentiles. Hopefully you have this wrapped up shortly. So you've probably heard of percentiles. Where I've heard it is lately anyways, in the last several years of my life, is with my children, because when they when a baby's born, they weigh them and they take their height, and then they'll be like, oh, your son or daughter is in the 70th percentile of height, and they keep a massive data set of all these statistics just to kind of track your child, and they measure their height and weight as they get older just to make sure they're in the healthy spectrum there. But what does it mean? What does it mean if my son was 50th percentile in weight and 90th percentile in height? So it's similar to quartiles, except that instead of dividing the data into quarters, we're dividing into 100 intervals. So the k% of the data are less than or equal to the kth percentile. So for example, the 70th percentile, if my son's height, we'll say, is in the, I think I said 90th in my earlier example, if it's in the 90th percentile, that means that his height is taller, is greater than or equal to 90% of everyone else. So when I said it's 50th percentile for weight, you hear 50%, you sound, oh, that's not very good. Well, it's not bad when you're talking about percentiles. The 50th percentile is the median. That means his weight, there's 50% of the data that is less than him. So if I was sticking with the way that this is worded, the 90th percentile means 90% of the data is less than or equal to my son's height. So let's look at an example here. We have the audio magazine tested 60 different models of speakers. Each gave one an overall rating based on sound quality, etc. Here's the raw score. So there's 60 data points here. So if the old Audio Maximizer Ultra 3000 scored at the 50th percentile, what is the raw score? So we're trying to find the 50th percentile. And because it's 50th, as I just alluded to above, that's going to be the median of this data. So we're going to find the median. We have the 60 data points. We're going to add 1, divide by 2. That means it's going to be an average of the 30 and 31st data points. So luckily these are already in order for us. And 15, 30, 45, 60. So the 30th data point is here. The 31st data point is here. The median is right, the divider between those 2 points. So it's going to be an average of 67 and 67. Which is obviously going to be 67. Now this just so happened to be the median. We'll see an example where it's not, like, what are you going to do if it's not the 50th? What if it's not the exact median? Well, what we could have done instead is, if we want to know kind of what we're looking for here, we would, if we wanted the 50th percentile of this, we would want to know what's 50% of the amount of data points we have. And that would lead us to the 30. That would tell us where we needed to go. Which is what's going to happen in this question right here. So we want the 90th percentile. So what we're going to do is we're going to take 90% of the 60 data points. So it's going to be the boundary at the 54th value and the 55th value. So going back to our data, we need the 54th data point, which is 15, 30, 45, 46, 47, 48, 49, 50, 51, 52, 53. Here's the 54th data point, and here's the 55th data point. So this is the boundary right here. 90% of the data is below this boundary, right? Because 54 data points is 90% of the data. 10% of the data points are above it. So it's going to be an average of these two data points. So it's going to be 88 plus 90 divided by 2 is 89. And then last question, I believe, homework's at the bottom there. Does the base blaster score 75 place it at the 75th percentile? So there's a couple ways you can do this. You can just go ahead and find the 70th percentile and see if it's the score, or have a look at where the score is and see if it's at the 75th percentile. We'll use the same method that we just used above. What is 75? I'm going to do this one in a different color just so that diagram, the data on the last page, is going to look pretty messed up. So 75th percentile, and there are 60 data points. So this is going to be the boundary of the 45th and the 46th. So going back here, 15, 30, 45, it's going to be this boundary. Because if you think about it, the 75th percentile, this boundary line that I drew right here, 45 out of 60, which is 75%, is less than or equal to that, whatever this value is going to be. So it's going to be an average of 79 and 81, which is going to be 80. That equals 80. And that is all. So the suggested homework is at the bottom. So this is the last lesson of the unit. So there will be an assessment. The assessment's actually already posted. So I'll also put up a little review, some review questions that you might want to work on, and just message me if you have any questions or concerns.